Chapter 8, Between Subject Design. There are two types of experimental research, within subjects and between subjects. This chapter is focusing on between subject designs, and the next chapter is going to focus on within subject design. As you see in this slide, the within subject design is a design in which we apply different treatments to the same group of participants. For example, we ask students to study under two different conditions: the silence condition and a condition in which there is a background music played while they're studying. And we want to see which condition or which treatment is more effective. However, in the between subject design, as you see on the right side, we do the same thing, but we work on two different samples or two different groups. The first group receives the silence treatment, and the second group receives the music treatment to see which treatment works better. If you use between subject design, you have to be aware of the limitations of this method and also the threats to internal validity. The first limitation is that in a between subject design, we need more participants. For example, if you have three conditions or three types of treatments, then you need three groups of participants. So if for each treatment you need 30 students, then in a between subject design you need 90 participants. The other limitation is the group differences or the individual differences, that because we're dealing with two different groups, there's always possibility that one group is different from the other group in terms of their performance or their characteristics. And the third factor is a chance of the increase in variance. If you have one group of participants, you have a limited range or a limited variance in terms of their performance and their characteristics. However, if you increase the number of groups, then it's more likely that you have a wider range of variance or a wider range of performance. An example of a group difference is when one group is smarter or taller or faster than the other, and because of this we are dealing with confounding variables that is totally unrelated to the experimental treatment. Therefore, we have two types of confounding variables. One is called the assignment bias, in which one group is different from the other group from the beginning, and it's because we didn't do random assignment, so it just happened that one group was higher or different from the other group. The other type of confounding variable is the environmental variable. The environmental variable are the factors that gonna change the result of our research after the initial assignment, which means even if you do a good job in random assignment and your groups are initially equal to start with, there is a possibility that the environmental condition for one group is different from the environmental condition for the other one. For example, one group might be working in a higher temperature, or the other group might be working in hours or times that the participants are tired or hungry or experiencing conditions that's not related to the treatment. Now, the question is, now that we know there are all these threats to internal validity, what can we do to make the groups comparable or equivalent? Basically, there are three ways that we can do that: random assignment, matching groups, and holding variable constant. Random assignment is when you have your sample, like you have 100 participants to work with, you randomly divide them into two groups of experimental and control. So everything about these groups is going to be randomly distributed, like their IQ, their income, their height, their performance level, their experience. Everything is going to be randomly distributed, so we expect these two groups to be equivalent. However, no random assignment is perfect. So even if we do it randomly, it may happen that one group is still different from the other one, especially if we're dealing with small sample. So random assignment works better when we are dealing with larger sample, but when we have smaller samples, probably random assignment does not help a lot. Therefore, we have other ways to make groups comparable, including matching groups. Matching groups is when you match your experimental and control group in terms of specific variables. For example, you match based on their IQ. For each high IQ in the experimental group, you have another high IQ in a control group. For each boy in experimental group, you have a boy in control group. This method is good when you have only one variable or at most two variables to match, because otherwise it's going to be hard to match the groups. And also it requires pre-testing. So if you have multiple variables, then you have to match them, and before you match them you have to measure like their IQ, their performance, etc. And the third one is holding a variable constant. Holding a variable constant means that you work on a specific range of variable that you are worried about being a confounding variable. For example, if you think IQ might be a confounding variable, you limit IQ to a very limited range. Or if you are worried about gender, you limit your research only on boys or girls. This is a good method when you have only one variable that you're worried about and you want to make 100% sure that this variable is not a confounding variable. However, if you do that, you need to know that you're improving the internal validity, but there is a threat to the external validity, because people are going to ask you, what's the point doing research only on this limited range of IQ or only on this specific gender? The other factor is variability. Like I said, variability is an issue when you're dealing with multiple groups of people. The more groups you have, the more likely you get a very wide range of scores. For example, if you look at this picture, you see two groups of participants. The mean or the average for control group is around 40, and the mean or the average for the treatment condition is about 50. So there is a 10-point difference. And as you see the picture, the experimental group is clearly higher than the control group. However, if you look at this picture, you see again we have about a mean score of about 40 for the control group and a mean score of 50 for the experimental group. So again, the difference is 10 points. However, if you look at the picture, it's not clear which group performed better, and the reason is the wide range. So if your groups are not alike, they are not homogeneous, it's very unlikely that you see a significant difference. But if, like in this case, if the groups are homogeneous, they are close to each other, then it's very likely that you see a significant difference. That is how a variance or the range can affect the results of your research.